Yeah, hello friends. In this video, I'll show you how you can containerize a two-tier application where tier 1 would be your REST API and tier 2 would be your MySQL database. This is my GitHub repository where you can download the entire source code. Okay, it's github.com/migration/spring rest docker compose demo. This demo already uses Docker file and Docker Compose file both. But in this video, I'm not going to explain you Docker Compose. In this video, I'll explain you the basic Docker file, how to create the Docker file for building this project, and how you can launch two separate containers, one for MySQL database and the other one for the REST API application. Okay. In next video, I'll show you how to use Docker Compose in it. So let's get started. I'm going to clone this repository. Remember, this is a public repository and you can go ahead and clone it without even need for GitHub account. You don't even have to sign up on GitHub for using this. So what I'm going to do now, a very simple thing. I'll just open my VS Code and I'll just open an empty folder there. Wait a second. Let me just clone this repository here. You can see here I'm in my Git folder, and let me clone this repository like this. Spring REST Docker Compose. So it will create a new folder called Spring REST Docker Compose, and I'm going to open this folder. Spring REST Docker Compose. I'll show you my source code as well, don't worry. There are two folders in here. One is DB folder and the other one is my API app folder. API app folder now contains the Spring REST application, which is a REST API basically. And this is my database. The very first thing I'm going to do now is to build a database image. And database image is very simple. I don't have any, I don't have any extra details in here other than just two files. An SQL file which basically is MySQL dump, which contains all the table script, like this is create table and this is insert statement. So DDL and DML both is merged into one single .SQL file. So this is my sample database basically, just a sample database. And this is my MySQL Docker file. Now let's try to understand what this Docker file is doing. The very first thing here I'm doing is, this is my base image. I'm using MySQL 5.7 base image. Okay, so this command will pull the base image and then I'm going to copy this .SQL file inside this image. Now, MySQL base images have a special directory inside those base image containers, and that directory is docker entry point initdb.t. Please remember, initially this folder is empty, and what I'm supposed to do is I'm supposed to copy this file inside this directory. That's it. MySQL, this official MySQL image is actually pre-programmed to pick up all .SQL files from this initdb folder and process them. Next, I need to provide my database environment variables. In Docker, environment variables are the standard way of passing values or information from outside the container to inside the container. And there are few standard environment variables that I need to set. It is also possible to set those variables on separate line, but I decided it's better to put them on one single line. Spaces are important here. And remember, these are predefined names. These are not user-defined values. I can't just write ABC equal to XYZ. You need to provide the correct spelling for them. And they're all in upper caps, upper letters. So MySQL database I want to create is OrderDB. I will have to make sure that whatever name I write here should match with this file name over here. Then this is my MySQL username. You are free to change this and use your own username. And this is my MySQL password. And there is one mandatory field, root password. Please remember, root password is for MySQL root user. And this is password for this Mahindra user. No entry point is required. It will take the entry point which is already there in MySQL 5.7 image. So let me show you how it will work now. What I'm going to do is I'm just going to now open a terminal here. Okay, I'm using PowerShell terminal, not issue. Let's go inside DB folder, because remember this Docker file is inside DB. And let us now build a DB image, app DB, and then dot. So I'm creating a new application DB image here. It's done. On my system, it didn't take much time. I'll tell you why, because MySQL 5.7 was already loaded in my system. Otherwise, it takes time to download that base image. Docker images, appdb. Yes, you will notice appdb latest is created 16 seconds ago and its size is 448 MB right now. Can I test run it? Yes. Let's do one thing. Let us do a quick test. Run. I'm going to give it a name, testdb, and then I'm going to provide here port mapping. Do you remember what port is used by MySQL? It's 3306, and image name is mydb. With this command, I should be able to create my own instance of MySQL DB. I did not use -d parameter, and because of that, it's actually giving me logs directly over there. I'm just waiting for that final message, MySQL is ready. Yeah, I finally got the message. Please remember the prompt will keep here. Okay, if I press Ctrl C, it will stop the MySQL engine. So I'm not going to press Ctrl C right now. I'm doing it only for quick testing. I have this very simple client tool called SQL Ictron. You are free to use any other tool of your choice. You can also use MySQL Workbench. Fine. Let's get started. We will now try to connect with this MySQL database to quickly check if the database is created correctly. I'm going to add a new database. It's MySQL and it's called appdb. It is currently running on my localhost machine, port 3306. Username is Mahindra. You will get all the other details from here. Username is Mahindra and this is my password for this database. So here's the password and I want to connect OrderDB. Yes, that's it. Let's test the connection. Connection succeeded. Save it. Now where is that database? AppDB. Here it is. Let me connect. Can you see all the tables in over there? I can now write very basic commands like select star from agents, and if I execute, do I have the sample database with me now? That's great. So that means I do have all the data with me now. I'll just press close. Database is working just fine. Let me just press Ctrl C to stop it, and I will delete this database. Don't worry, I will show you later how to recreate this. I have some other plans for it. So what I'm going to do is I'm going to just delete this testdb now. Docker has a command docker stop testdb to stop the container successfully, and then finally docker rm testdb to delete this container. Don't worry about it. I'm going to create it sometime later. So that's it. Now the interesting part is about the API app. Now for API app, this is a Maven project, and let's look at the Docker file for it. The Docker file very first line is it's a multi-stage build. So we first need Maven. So we are getting Maven, creating a folder, and then copy dot. Please remember dot here means current working directory. So copy whatever is there in this directory whatsoever. Copy everything to this app directory inside this Maven image. And then run this command mvn package. Skip test. I do not want to run any unit test right now. Okay. Fine. Then next step. Use OpenJDK 8. Remember this project is self-sufficient. Right? It contains everything what is required. It's a Spring Boot application. It doesn't need Tomcat to run. So just need OpenJDK. Again create work directory, and here you will see copy command is using from build. That means from this image. It's going to copy app target star.jar built by Maven into this final image app/API app.jar. And we are also making sure that we are using port 8080. Now the much interesting part is the environment variable. Can you see here I have manually written environment variables like db user, db password, db name and db URL. Don't worry, these are values which I'm going to override later on. These values I'm going to override them later. I need to pass these values later on at the runtime if I want to override any of them. And then finally the command that will launch along with this container is java jar app/api app.jar. This path we need to provide. So that's my Docker file, and it's now time to build this Docker file now. So let's say I created Docker build -t, and then I'm going to call it app, or let's say API app, and then dot. Oh, wait. My mistake. I will have to go inside the API app folder and run this command. Okay. So let it build a new image. I successfully built this project now. Fine. The container image is also built now. I have got two container images built now, one for database and one for application. And now the final part. How do I run this project? So what I need to do first is run a database first. There are a few things I'm going to make sure that I change. There is no port forwarding now. I'm going to run this in a detached mode, -d, so that my prompt will be ready for me to write next command. It will run in background. I'm going to give it a name, testdb. So this is my database. Let me check IP address of it by writing docker inspect. Container which I want to inspect right now is testdb, and I need to provide the format, or you can say the format string here. So here I'll just write, wait a second, it should be network config IP address. I don't know whether this format is right. I'll do one thing, I'll just write inspect testdb without any kind of filter. It will give me a large JSON file. I will just scroll up and down and locate the IP address from there. Every container gets its own IP address. So here it is. Wait a second. Yeah, IP address for this container is 172.17.02. That means IP address which I have written over here is perfect. It's perfectly all right. But let's just assume that IP address doesn't match. When you run the container, your container has got a different IP address. So how do we make sure that it works? Okay. So what I'm going to do is I'm going to now run my next container image. What was it? It is API app. So here for API app, I'm going to create an image out of it. I'm going to run it in a detached mode, but I need to do the port forwarding here this time. And I need to provide the environment variable, which I will provide using -e. Using -e, I need to provide the DB URL. So let me say DB URL is equal to 172.17.0.2. So this is the way you can override it. Now this should be the URL for the other container, the database container. This is how it will be able to reach out to it. Now let me press enter and see what happens now. It will launch the container. It's now accessible on port 8080, and I'm able to run it now. Let's see. I'll just create a new window, localhost 8080, and that's my application. It is a RESTful application, and you can see it's just giving me these details. There is, by the way, a sample API URL there, API/customer. If you write this API/customer, you will get customer data. And if you want, let's say, agents, you can write API/. Oh, wait a second. Looks like I have not implemented the other parts. Fine. API/customers, and it is able to fetch all the data from database. And you will notice like there are multiple records in here. How many are there, by the way? There are 24 records I can see. Let me check if I can fetch a particular customer as well. No, maybe I'm writing a wrong value. Customer code I need to write. Okay, fine. I'll write customer code C00002. Yes, that's the customer call port. Can you see that? Now all this data is actually fetched from a database. You don't believe me? Okay, fine. I'll prove it. What happens if I stop my database container? What is it? Test DB, right? What will happen if I stop my database? Database is now no longer running. Now what will happen if I make any request here? Let's see. It's not working. It's taking too long. That's because my application is retrying several times to check if database is available. Remember, it's a JPA project. So it's not going to give up only on first attempt. It will try several times. And then all the time it exhausted all the things, you can see the error message. Unable to acquire Jdbc connection. And the reason why I'm getting this error is because database is not responding. What will happen if I start the database? Start DB. DB start will take some time, like maybe 1 or 2 minutes. After DB is started, yes, data is available. I know you people might be asking a question. It's okay. From Docker perspective, we know how to pass environment values. But how do we include these environment values in Spring Boot project? And that is the best part of it. Let me show you something about application.properties file. Do you find anything interesting in application config file, the properties file? Look at these special symbols over there. These are placeholders. DB URL, DB user, DB pass, DB name. Remember, these names need to exactly match with values which I have written here. Can you see them? DB URL, DB user, DB name, and DB password. That is how the values will be picked up. And there is no limit on how many environments you can define in Docker file and how many environments you can pass to Docker command. Fine, that's it for today. Next time I'll show you how to implement this with Docker Compose. That's enough for now.